Hey, Madog here. I promised you guys a video on how to make one of these magnums. So anyway, this is one of the flashlights that there's been links to on this forum thread. You can get them 2 for 1 in the blue like I've had before, or with the red. This black one I happen to get at a discount place. It's actually I would say exactly the same manufacturer. The one that I posted here just not too long ago on Deal Extreme's got 7 different colors. Actually, I think the green one's kind of kicked, so I might order one of those and make a few of these up and have them for sale for people who maybe soldering iron challenged. This of course just unscrews off the back. That's your normal battery housing. Set that off to the side and we're not going to do anything at all with it. Inside is the 3 AAA cell battery holder. We're not going to use that at all either, so you can chuck that. The easiest way to get this all apart is to just take a socket. This is a deep well 5/8 inch. Go ahead and just slip it right in there. Give it a good little wrap and everything will come flying right out. This is the printed circuit board, which has a spring located on it. Has the 9 LEDs, which definitely can be utilized for other goodies later on. And also the lens. I'll go pick that up off the floor now and show that to you in a sec. Okay, back, and here's the lens. Okay, so then you have just a nice tube or battery housing is what we'll be using it. To get this all apart, I just take my soldering iron and this little chrome piece right here, it slips right off, which holds the LEDs. Hang on to that. I just slowly take this and start working around by getting the edges of all the LEDs hot and pushing them towards the center. Going all the way around this. They'll start to fall out as I proceed and start to unglue them all or unsolder them all. There's one dead center, and to get it out you usually have to take and unsolder the spring. The faster you work doing this, the better off you are. Try not to burn your fingers up. Okay, now I've got that one center one here left. Can't really get to it, so I'm going to desolder the spring, set it aside, and then I can take the last one off. Okay, we want to hang on to the printed circuit board. We're going to be utilizing that in a minute. And let's see here. I'm going to revamp the spring, and I'll show you how to do that. Okay, one of the inherent flaws of one of these flashlights, if you ever owned one, is as you're trying to utilize it, it seems like the thing switches on and off, and that's because it actually makes connection with these 3 points of just a buildup of extra solder on this little rim inside here that you can see reflecting. That's what makes your negative contact. You can't, of course, solder to aluminum, so it makes it pretty difficult. Okay, I've moved into macro mode here for a minute. Right here is where, on this pad, is where our spring got desoldered from. The spring actually floats over and around this pad right here, so you want to make sure that these 2 pads don't short out. If they do, I would say bad things could happen because you're definitely grounding out your batteries. So I'm going to resolder the spring on to this point right here. Check it with my meter to make sure that I don't have a short circuit between these 2 points. Okay, I've resoldered the spring back on the printed circuit board. I'm going to check it now and check the outer ring against the inner ring, and there's no continuity there, being then we have a good isolated circuit. I would say that it's a good idea to take and add a little extra solder here at these points. This is where your grounding connections are going to be made inside the flashlight housing. and a little fresh solder at those areas will always help. Okay, now what I'm going to do is I'm going to get some wire, and I'm going to add pigtails off of the positive and the negative pad traces of the board. We're going to be using outside as the negative and center as the positive. Okay, I needed a little bit of wire, so I went and hacked up a telephone wire cable that goes from the wall to the telephone. It's usually got some pretty good small format or small gauge telephone wire in it that's stranded. It's meant to put up to the riggers and moving around a lot. Green, red, so we're just going to call red positive and green negative at this point. I'm going to take the green. I've already tinned this end, which means I've just taken and added some solder to the bare copper connection wire that I've stripped the insulation off. I'm going to take and I'm going to put this in the printed circuit board in any of the outer ring holes. And once I get this all put together, I'm going to zoom in on some macro and get it up close and give you an idea of what I've actually done very up close. I'll take and solder this in, just like so. You can always use like a third hand, it seems like, when you're doing some of this stuff. Let's see. Instead of wasting video time, I'll just solder this in real quick, and then I'll do the center one, and then we'll zoom in and do a close-up of what I've done. Okay, what I've done here is anywhere along this outer ring is all our negative connection, and anywhere on this inner ring is a actual positive connection. So what I've done is I've utilized this hole here for my positive connection, this hole here for my negative connection, just by simply just putting the wires through and then solder on the printed circuit board in those two places. This is going to give me my power supply lines to the interior where the rest of my electronics will go. Okay, well, I've got the printed circuit board in, as you can see. I'm setting it in here just to get an idea of the depth. We have a ½ an inch of room to play with in here, but the actual lens set in probably a good 1/8 of an inch. I want to utilize as much space and get everything back down near the printed circuit board as possible. I've got a blue LED fresh from Radio Shack right here that I'm going to install in this. I'm actually going to use the snap-in LED holders. Because of that fact, I am going to have to use a resistor in line to limit the current, because I'm not going to utilize the little blue resistor out of the battery. So I'm going to need to put a 100 ohm resistor in here also, and then I've got some of these little low profile tactile switches that I'm going to use as a tactile switch, and I'm going to show you how to raise this up a little bit also. Also got some pink LEDs here. Thought I'd build one of these in red with maybe a pink LED. Maybe one of the girls wants it. Anyway, so I'm going to measure this out and find out exactly where I'm going to drill the holes for the manual switch and the LED, and then I'll be right back. Okay, well, I've measured my tactile switch, and I found that it's actually 1/4 inch across. The LED housings are requiring a 1/4 inch hole, so I want to come a 1/16 off the printed circuit board, so that puts me at 3/16 up from the printed circuit board. It's a full ½ an inch on clearance, so I'm going to measure 5/16 from the edge of the start of the housing back, and that's where I'm going to drill my 2 1/4 inch holes. Actually 1 1/4 inch hole, and let's see, probably another hole that's about 3/16, just because I just want a little bit of clearance for the tactile switch button. I don't want it to completely fall through. So I'm going to drill 1 3/16 hole and 1 1/4 inch hole in the housing, 5/16 from the front. Okay, here I've drilled my 2 holes. I've got a 1/4 inch hole here for my LED holder, and I've got a 3/16 hole here for my tactile switch. They're not 45 degrees apart or 90 degrees away from each other. They're probably closer to 45. When I press the tactile switch, I kind of like to have the LED right underneath my hand. That way, if I'm somewhere where I don't want the LED, I can always still put my finger over it, be more discreet when I'm vaping. Also, when I'm driving down the road at night, sometimes the LED can be kind of bright. So anyway, I'm going to go ahead and go back to wide mode here now. And okay, here's my... Okay, we'll go ahead and put this LED in now. You want to take and snap the LED holder into the hole, like so. Makes for a really nice, clean look. And then put the LED into the housing from underside. Just like so. Need to have something to pry these tabs out on both sides of the LED so that you can get it to go in the rest of the way. This isn't the proper use of test probes by any means. And there's our nice little blue LED already in there. For the tactile switch, I find the best way to mount them is with the infamous hot glue. And I will go and hot glue the tactile switch in right here, and be back with you in a minute and let you see how it looks. I think that everybody's used a hot glue gun and can figure out how. I'm going to now hot glue the switch in. One thing to keep in mind when you use tactile switches is to find which 2 legs. This switch actually has 4 legs. Find which legs are being switched. You want to switch this in the normally open position. That means when the button isn't being pushed, that the circuit is open. There's no continuity between those 2 legs. So on this particular switch, there's 4 legs, and you can use either switches on either legs for the closing of the switch. These 2 on the side is what I'll probably end up using. I'm going to go hot glue this in, and then I'll be right back with you. We'll get a couple close-ups. Okay, I've got the switch hot glued in now. As you can see inside here, we've got the 2 wires for our LED. We've got our green and our red, which green we're going to utilize as our negative. Red's going to be our positive. I've mounted my switch so I can access both of the connections at the top of it for my switching needs. And you'll notice that my tactile switch is a little low in the case right now. I'm going to show you how to fix that. By the way, if you've thrown the 9 LEDs you got with the flashlight away and your tactile switch is low like this, go root them out of the garbage can, because you're going to be needing one here in a minute. Anyway, now we're going to install our 100 ohm resistor on the long leg of the LED and wire it over to one side of the switch. We're also going to be taking then and running some other wiring here. So I'm going to switch this off, and I'm going to proceed with prepping and getting everything ready for the resistor installation here. And for the resistor, we're going to be using a 100 ohm carbon film resistor from Radio Shack. So we'll go from there. Okay, we're getting ready to install this little 100 ohm resistor. I've cut my LED leads real short, taking note of which one was the long one. That's our positive leg of our LED. I'm just going to put a little solder on that long one. And then I've applied a little bit of solder here already to the end of the resistor. And then all I have to do is just touch those together with the iron, and everything will flow real nice, and then we'll hook up here. And blow on it a little to get everything to set up. Then I'm going to take a little piece of heat shrink tubing. I'm going to slip that over this. I'm going to cut that a little bit. It's a little too much. Got a little carried away with how much I needed. There we go. And then I'm just going to run my iron down the sides of that heat shrink tube, and it'll suck it up around my connection. Guess I could have used a smaller heat shrink tube. Okay, so now we've got our resistor hooked up there. We're going to bend this lead around and go to the side that is closest to us to the switch. And we're going to solder that lead on right there. I'm going to trim off a little bit of this. Okay, here we are really close up. You can see where I've taken and put the resistor on my LED. I've got it tucked in down here, and then I went back around and I soldered it to this side of my switch. I'm also going to solder a wire to this side of my switch. It's going to come out to the center leg of my atomizer connection, and then over here I'm going to take and run this red wire, which is the positive wire from our battery. I'm going to run it up to there. So I'm going to solder this red wire right there, and then I'll be right back with you. Okay, I've taken and took the wire that was from our printed circuit board up, and I've soldered it to one side of the switch here. I took the remainder of that wire, I stripped the end on it, and then I soldered it to the other side of my switch, the same leg that I soldered the plus side of my LED to. So now what's going to happen is when the current, or when the power comes in here to this switch and the switch button is pushed, it's going to give power to both the LED and the plus side leg here of the atomizer. I'm now going to wire the negative lead over here to the negative side of the LED right down here, and then I'm also going to move it up and take the remainder and solder it on here as well to pigtail off of that to use as a the negative side to the atomizer. Okay, now you can see where I've taken the negative wire that came off the printed circuit board, goes up, hits the negative side of our LED, and then the remainder now comes out. This will go to the negative side of the atomizer. Red will go to the positive side of the atomizer, or the center leg. This will go to the outside leg here. When you took the flashlight apart, there should have been this little part that was had a whole bunch of little holes in it. That was the support for the LED. Just grab the center of these and start to break them all out. We want to get rid of all of this material that's here on the inside. We don't want it anymore. This is going to act as a support for the whole unit. You're also going to want to take and cut this in half like so, and then set it here and get an idea of how much room around the edge has been taken up by your electronics, and then cut that, because your either the lens or printed circuit board, whatever you decide to use, will be supported by your electronics over here. But then this also gives us a support on this side for our printed circuit board. I found that using printed circuit board material is much better than using the factory lens that came with the unit, The lens is actually real flimsy. It doesn't work very well, and it doesn't have a really good tight fit. And if you cut one out of printed circuit board material, it really makes a big difference on how it fits and how well it fits. But save this lens, because what you can do is you can actually use this as a very nice pattern for transferring to the printed circuit board material. And I'm going to go grab that right now and set that up. This here is just two-sided copper-clad printed circuit board material. It's got actually a very thin layer of fiberglass in through here, and then it's copper-plated on both sides. Here's a standard battery connection that I've kept out of a different battery mod. We're going to take this, and I'm going to utilize this on this Magnum here. I'm eventually going to probably put my more commercial tire valve battery connection on this unit, because I think I'm going to keep the black unit. I like the color a lot more than the blue. So anyway, right now what I'm going to do is just put this lens on here. We'll trace this out, and then I'm going to cut this out, and we'll take and make it from there. By the way, a really easy way to cut out these discs is just to rough cut them and then use a belt sander to grind your way, or a grinder to grind your way to the circle. You can get really exact that way. This is a belt sander, and as you can see, all you have to do is just take this and work it around, and it will really take material down fast, as you can see here in a sec. I think I've got about a 80 or 60 grit paper on here right now, but then you can just slowly work that all the way around, make a really nice circle. Okay, here's the little disc that I made out of the printed circuit board material to fit in the top of the flashlight case. Here's my battery connector. The hole I drill is a 21/64 hole. It makes for a very tight fit. Easiest way to install this is by taking and I generally just kind of chamfer or take the edge off with my pocket knife, Leatherman tool again, and then get that started in there, then turn it upside down as so. This isn't a very good table to do this on. It flexes an awful lot. I'm going to take and rather have just a little too much material than not enough. Put this in like so. Set it like so. And take the same socket that we disassembled the flashlight with, put that over the top. And I'm going to have to go find a more suitable table because this table flexes too much. It's one of these plastic tables. So I'm going to go put this together and on a nice piece of concrete or something, and then I'll be right back. Okay, here's the connector after I've pressed fit this battery connection into the disc. As you can see, it's a very tight fit. I'm going to now take and use some two-part black JB Weld epoxy, and I'm going to epoxy around the edge of this just for even more added strength. This is going to help protect the flexing action that will occur when the atomizer and the cartridge is attached. And we'll just give it a little bit more oomph there. So you could also use the Magnum connection at this point, or not the Magnum connection, but the tire valve connection, which gives even substantially more flex resistance. If you're a contractor or something like I am, this is a really good way to go. You know, these things are really handy too as a flashlight. If you turn the atomizer, take the atomizer off, you can utilize it for that. Okay, here's the epoxy fillet that I've created on the back side of the battery connection. I have added some little solder places there where we're going to be soldering the red and the green wire to. I'm going to let this dry, set it aside. In the meantime, I'm going to address the issue of this tactile switch. You can see that it's a bit recessed. It's not sticking up to make it real easy to hit. And how we're going to do that is we're going to take one of these LEDs that came out of the flashlight itself and a handy dandy razor knife, and what we're going to do is put that about where I want it, about right there, and then I'm just going to roll back and forth to score the entire top of this LED. Just like that. And now I'm going to take and put my hand over it like so to capture the parts and give this a quick tap. And I'm going to need another tap. There we go. And what we end up with is this little piece off the tip right here. And I'm going to rework that on some sandpaper and get it to the size I want to be used as the top of my button. And I'll show you that in just a second. Okay, here's what it looks like after I've sanded it down. That's what I've got, nice little button top here. What I'm going to do now is I'm going to use the razor knife again to take and slice some of the edges off, because it's a little wide for my hole that I've got, and it fits a little snug for what I would like. So I'm just going to continue to go around the edges of this, trimming away little bits of plastic, and when I get this all complete, I'll be back again. Okay, I'm back, and I've got this little teeny tip of an LED right here, and what we're going to do is we're going to use that to take and make a little teeny bump up for our switch. It's going to be really hard to keep that in there and show you. Maybe I can go this direction. And what that's going to do is give us just a little bit higher of a tactile area to touch, which is going to be really nice. Okay, and I'm going to hot glue this on. I use hot glue instead of like super glue, because super glue tends to wick, and a lot of times super glue will wick right into your tactile switch, and then you're replacing the whole switch assembly. Okay, there we go. It's all hot glued in there now. Nice little divot switch right there. Makes it real easy to push. Real nice. Okay. Alright, I think our headpiece here is nice and dry. So let's solder this together, and I'll show you how this gets press fitted back in there. When you're soldering on this battery connection, you need to be real careful, because you can heat this up way too hot, and there's a silicone gasket right here that is the insulator between the outer and the center conductor of the battery connector. You get that center piece too hot, or even the outer piece too hot, you will melt that. So I would suggest when you're making these connections to give it a bit of a break as you're doing this. You don't want it to get too hot. It's a good reason to take and build up a little solder bead right there. That will really help in making that a lot quicker process. Okay, so there we go. The red's in the center, green's onto the outside. That was our ground. Red is our center. We need to make sure that when you put your batteries into your compartment, you put the batteries in positive first. Will the e-Cig not work? No, it won't. It'll work just fine. The problem is your LED won't work. Your LED has to have a positive and a negative polarity. Okay, now I wanted to concentrate on the other end of the little machine here. This is schedule 40 PVC pipe, ½ inch. It needs to be schedule 40 because if you can see the difference in this is schedule 400 psi. This is schedule 40. Can you see the wall diameter differences here? And that wall is imperative to making up the space in the inside for the CR2 batteries. You could also take and use a thicker wall on the inside diameter, or sheath that up maybe with tape or a cardboard tube, and also a 14500 3.7 or 3 volt lithium ion rechargeable would work in this also, and give you about 3 to 4 times what a normal DSE 901 battery. That just simply drops right in there as such, and then we take, I don't have any more batteries, so I'll take the ones out of the one I've been using here, real good. These two CR2 batteries, these are going to be in series, so that's going to produce about 6 to 6.2 volts, wrong end, 6.2 volts standing. We're going to put this on here, and then we've still got this switch here which we can use as a main battery on and off. So I'm going to do some initial checks on this, and then I'll be back to you. Okay, we basically got this unit pretty much all put together at this point. We want to do some preliminary tests. The first and foremost easiest test would be just to take and check to see that the blue LED is coming on. That's telling us that we've got power going through our switch. I would test it just very quickly. As long as it works adequately, then you can go ahead and move up. If you have an ohm meter, go ahead and put the red lead to the center of your connection, black lead to the outside of the battery connection, and push the button and check to see what kind of voltage you get here. It should be somewhere around 6.5 volts. If you have this hooked up with an atomizer and we're using it, and the atomizer was heated up, it'll probably run about 5 volts with the 5 volts with it under use. And I have put some current ratings there and things of that nature. So everything is looking pretty good. We're going to go ahead and button this one up. We're going to tuck these wires in here real neatly. Don't forget to have that chrome piece in here. This is going to provide a depth measurement for how far this can go in. These go in a lot easier if you have the main switch button here on the bottom. Okay, we're going to assemble this and button it all back up, put it back together. Easiest way to do that is just with using the socket again. You want to put it in on this side where you have the spacer, and then level it to your electronic side. So we'll put that side down first and then push it in until we get a pretty level appearance. It's about right there. It's a little off. We can take our spare atomizer and screw it on and do some initial tweaking here to get it back into a more direct perpendicular position. And there we go. It's all together. We'll get some batteries in this and we'll see how it works. Okay, I've got this all assembled. The batteries are in. We are working, and these flashlights came from a local department store, and they got this really neat little performance tool logo on them, but there's this ugly white China sticker on here. That's got to come off. But anyway, really nice looking, all black. I think it looks really kick. Copper plate right there. Probably going to have to paint that black or flat black or something. But anyway, let's see how she works. Yep, tons of vapor. Sounds good. Alright, well, happy vaping, and if you got any questions, feel free to post to the forum, or you can send me a private message. Have a great day, and thanks for watching.